Hello everyone, this is Sanjana and today we'll be talking about topological sort. So beginning with the topological sort, let's give it a fancy name, that is sorting the chaos, a topological journey. So let's begin with the chapter. Welcome to the introduction part. On this presentation, we'll be talking about topological sort. A fundamental concept in computer science, topological sort is a powerful algorithm used to solve a wide range of problems such as task scheduling, dependency resolution, and job sequencing. By understanding how it works, you can improve your computer skills and become a more efficient in problem solving. Let's begin. What is topological sort? Topological sort is a fundamental algorithm in which computer science that arranges nodes in a directed acyclic graph, that is also known as DAG, in such an order that every node comes before the ones that depend on it. This means that if there is a path from node A to node B, then node A will come to node B in the sorted order. So, to illustrate this concept, let's consider a scenario where we have a list of tasks that need to be completed in a particular order. If task A depends on task B, then task B needs to be completed first before task A. We can represent these dependencies using a DAG, that is also known as directed acyclic graph, and then use topological sort to determine order in which the tasks should be completed. Moving forward, we have applications of topological sort. In applications of topological sort is a fundamental algorithm used in various real-life applications. One such application in task scheduling, where tasks are executed in a specific order based on their dependencies. For example, in a software development project, the compilation of code depends on the successful completions of unit tests. Topological sort can be used to determine the order in which these tasks should be executed. Another application of topological sort is dependency resolution, where software libraries or modules are installed in a specific order based on their dependencies. For instance, a web application may require multiple library functions correctly, and these library functions may have their own dependencies. That was all about applications of topological sort. Moving forward, we have topological sort algorithm. So, as we have seen in the first slide, topological sort is a very important algorithm. The topological sort algorithm is a fundamental concept in which computer science that allows us to organize data in a meaningful way. The process involves creating a graph, identifying nodes with no incoming edges, and removing those nodes from the graph until there are no more nodes left. To create a graph, we start by defining all the nodes and their relationships. Each node represents a task or activity, and the relation between them represent dependencies. Once the graph is defined, we can begin the topological sort algorithm by identifying nodes with no incoming edges. These nodes represents that can be completed immediately without any dependencies. We then remember nodes from the graph and repeat the process until there are no more nodes left. Moving forward, we have topological sort versus breadth first search, that is also known as DFS. Topological sort and depth first search, also known as DFS, are two popular algorithms in computer science, but they have been distinct differences that make them more appropriate for certain tasks. DFS is a graph, or depth first search is a graph traversal algorithm that explores as far as possible along each branch before backtracking. It can be used to find all connected components in a graph or to search for a specific node. On the other hand, topological sort is used to order nodes in a directed acyclic graph based on their dependencies. It works by repeatedly selecting nodes with no incoming or removing them from the graph. Therefore, it is important to choose the appropriate data structure for the graph representation to optimize the time complexity. The space complexity of topological sort is also dependent on the data structure used for the graph representation. If an adjacency matrix is used, the space complexity can be as high as big O of V square, whereas if adjacency list is used, the space complexity can be big O of V plus E. So moving forward, we have challenges in topological sort. One of the main challenges in topological sort is dealing with the cycles in the graph. A cycle occurs when there is a path from node back to itself, which can cause problems when trying to determine the order of tasks or dependencies. There are several ways to handle cycles, such as detecting and removing them or breaking them by adding additional nodes or edges. Another challenge is incomplete data, which can occur when there is missing or incorrect inputs in the graph. This can lead to errors or unexpected results when performing the sort. To address this, it's important to ensure that all necessary data is included and excluded before running the algorithm. Topological sort in practice. Topological sort has a wide range of practical application in various fields. In software development, it is commonly used to determine the order in which the task should be executed or to resolve dependencies between different modules. For example, when building a web application, topological sort can be used to ensure that all necessary libraries and packages are installed before running the code. In supply chain management, topological sort can be used to optimize the flow of goods and materials through the supply of chain. By identifying the dependencies between stages of the process, it is impossible to minimize delays and reduce costs. Similarly, in the workflow management, topological sort can be used to ensure that are completed in the most efficient order, minimizing downtime and maximizing productivity. Topological sort in a particular programming languages. Python provides a built-in module called heap_queue that can be used to implement topological sort. The heap_queue module provides functions like heap push or heap pop that can be used to create a priority queue, which is essential for implementing topological sort. In Java, topological sort can be implemented using the depth first search algorithm. The algorithm involves creating a stack of nodes, creating each node in the graph. When a node is visited, it is marked as visited and pushed onto the stack. After all the nodes have been visited, the stack is popped to update a topological sort order. Best practices for topological sort. Coming to the conclusion. In conclusion, we have learned that topological sort is a fundamental concept in computer science that allows us to efficiently solve problems related to task scheduling, dependency resolution, and job sequencing. By understanding how topological sort works, its real-world applications, we can improve the efficiency and effectiveness of various processes. We have also discussed the topological sort algorithm and its complexity, as well as the challenges that can arise when using it. However, by following best practices and implementing the algorithm correctly, we can overcome these challenges and reap the benefits of topological sort. Overall, the topological sort is an important tool for any computer scientist, or software developer to have in their arrangement. By mastering this concept, we can optimize our workflows, improve our code, and ultimately achieve greater success in our project. Thank you for your attention. Now we would like to open up the floor for any questions or comments you may have. If you have any questions, please mention them in the comments. Remember, topological sort is a powerful tool that can be used in a variety of real-world scenarios, whether you are building software applications, managing supply chains, or organizing workflows. Topological sort can help you achieve your goals more efficiently and more effectively. That was all for today. Thank you so much for your attention. Have a nice day.